Welcome to this demonstration of Percepio Tracealyzer. Tracealyzer provides visual trace diagnostics for developers of embedded and IoT software. This is based on software trace data that we analyze and visualize to make it really useful in everyday development for verifying and improving the software design and the system performance. Tracealyzer allows for a top-down workflow where you can spot anomalies in visual overviews and reports and then easily drill down into the details. One example is the CPU load graph. This shows how the processor time is distributed over the timeline. Here we have a horizontal timeline, so time goes right. We can zoom this view independently of the trace view to get more overview. And if we click on any of these bars, it shows us what happened there. Let's take a look at the communication flow graph. This is a dependency graph that shows the runtime interactions between the different tasks and interrupts in the system. Who is talking to who in runtime, basically. This is generated from the trace data. The rectangles are execution contexts, actors like tasks or interrupts, and the ellipses are objects like queues, semaphores, mutexes. The arrows are the API calls that form dependencies between tasks or interrupts and these objects, like the HMI task is using this particular queue, for instance. You can click on the nodes in the graph to see a list of all operations on these objects, and then click in that list to find them in the trace. In the case of a queue, for instance, we can see a visualization of the buffering in the queue and match the send with the corresponding receive, and thereby follow the data flow through the trace. The trace view is vertical by default. Time goes downwards. This makes it natural to scroll with the mouse wheel, and it also allows for showing event labels in the trace. Currently they are disabled in the filter, but we can enable them like this. The leftmost part of the trace view is the scheduling field. The columns are what we call actors, tasks, or interrupts. The solid rectangles are what we call fragments, the time between context switches, so uninterrupted execution. This blue outline, when you select a fragment here, is what we call an instance. This is typically a single iteration in the main loop of a task, and it can be multiple fragments if the task has been preempted. The visualization scales to large amounts of data and performs well even when zoomed out over several minutes like this. We're now looking at 3 minutes of trace data, 700,000 events, but you can still see the distinct modes of operation in the system, and by changing the filter we can see individual events of importance, even in this very zoomed out view. To zoom the view, you can hold down the control key and either use the mouse wheel or make a selection like this to zoom in. The event log is the most detailed view in Tracealyzer. It shows the recorded data as is, event by event. I like to think this illustrates the need for visualization. Software traces are mostly repetitions of the same patterns, but it's often the deviations, the anomalies, that you're interested in. But with this amount of data, a plain listing is not very useful as a starting point, unless you know exactly what to search for. But once you know what to search for, you can do it here. Just type in a few characters like this, and select apply or hit return, and only the matching events are then displayed. This particular event is what we call a user event, produced by explicit application logging. This way we can see the values of a variable or when a certain point is reached in the code. Let's take a look at the user event signal plot. This shows a plot of the data we have logged as user events. Currently we see just the target pos variable, but let's add the others. If you double click on a data point, you see the label in the trace view like that. This is really powerful in combination with live trace streaming, where you see the data in real time. In streaming mode, the data is transferred continuously from the target system to Tracealyzer and processed on the fly. And this way you get these live animated views. This gives you an immediate feedback on what the system is doing. If you're pushing a button on the device, you'll see directly the impact on CPU load and user event signal plot, etc. We stop the recording when we're finished and then enable all the capabilities of Tracealyzer. There are plenty of other features, so I invite you to sign up for an evaluation and start exploring Tracealyzer today. Thanks for listening and good luck with your development projects.